Hey guys, so with this tutorial we're going to start talking about the jit matrix. And what that is essentially is kind of like a storage container of pixels. It's an array, it's in a spreadsheet, and it's just going to teach us a lot about how visual image is represented by the computer and by Macs. It's kind of the building block of whenever you see the green patch cord. If I make a jit.movie, and you have that green patch cord right here, it's matrix data that's coming out of that. And once we know like what specifically that's comprised of, then we have a better understanding of how we can manipulate it and what we can do with it. So just to switch things up, I'm not going to do the movie object this time. I'm going to do jitgrab. And grab is, you can see it says digitized video from external source. When it says external source, what it's really saying just your web camera. And if you have like a Apple laptop, it's probably just going to default to the one, and right above where my mouse cursor is, it should turn green. And I have to give it a message. You remember in the JIT movie we said read, but we're not reading a file here, so the jitgrab expects an open message. You can see it's a method that says open a sequence grab component. That's a little obtuse, but what it's just saying is turn your camera on. And if I lock the patch and hit open, like I said, if you're on an Apple laptop, you see that green light kind of pop up right there. But it's pretty similar in the same way as the JIT movie object. If we send it a bang, I guess I'll do that first just to get everyone seeing that. And then this time I'll make a jitp window, and that's just a patcher window. I'll just label that so you know how to make that. And if I lock the patch here, and you can see every time I send a bang to it, it'll output the current frame from the camera. But we want it to output enough frames that it looks like a moving image. How do we do that? 30 times a second. I'll make a metronome or a metro. And I'll do 1,000 divided by 30 equals 33.333 or 313 or something. It's about the same. And I have a toggle to turn that on. And there we go. Now we have a nice moving image, nice camera image of me talking to you in this tutorial. I'm going to turn that off for a second. So what's coming out of here though? Like, I mean, obviously it's the frame of a video, but like, how is that frame, what's it composed of? What's it comprised of, I guess you could say. And one object we can use to kind of check that out, I love this object, it's called jitfps GUI. And it's a GUI object, so it's going to change when I hit enter, and it turns into this thing. And I can hook up the jitgrab to it and lock the patch. And now you can see, actually this is pretty cool, like I can get my frame rate, and logically this makes sense. We're sending a bang every 33 milliseconds, and that averages to 30 times a second. You see there's a little variability depending on if my computer speeds up or slows down. But if I click on this thing down here, it gives me some other things I can start to display. And I can check what the planes are, how many planes of information there are. There are 4. I'll get to what planes are in just a second. I can check the type, and when it says type, it's saying the data type, and it's a char data. I'll also explain that. And then this one you might know, this is just the dimensions, like it's the resolution of the camera. In this case, our camera is coming in at 1280 by 720. Jitgrab does let you, its first argument after you have it, you could just say 320 by 240. Now I need to open the camera again. And it's a little hard to tell, but the resolution's a little lower here. But now we just hard-coded in that even though this camera is designed to be 1280 by 720, we are downsampling it and forcing it to be 320 by 240. Why would we want to do that? Mostly because it just requires less processing power. And that's something you're going to have to balance as we start to build these systems out. If you have a movie file that's HD, or you have a camera that's HD, when I say HD, I mean like 1920 by 1080, the higher the resolution, the more work your computer has to do. So that's just something to keep in mind as we go through this. So I'm just demonstrating that here for you. You don't need to. But there's things I talked about. Planes, data, or I guess it's data type, and dimension. And that's kind of what we're representing everything as. So I'll move this back down here. And that all these things comprise the jit matrix object. If I grab this jit.matrix, and it expects 4 arguments. It expects how many planes, and normally we would work with 4 planes. The reason we have 4 is because it's the ARGB planes, or alpha, red, green, blue. And like when you're using P5, this is about the same thing you used before. You know, when you wanted to play with color, you would mix like 0 to 255 on the red plane, 0 to 255 on the green plane, on the blue plane. And when you mix red, green, and blue together, you get the full color spectrum. Maybe, I'm sure it's not technically the full color spectrum, but you get what I'm saying. But we need all 4 of these planes mixed together. Alpha we're not going to touch on too much today. I'm going to talk about it more for the next class. There's a lot of fun stuff we can do with it. But red, green, and blue is kind of what we're working with here for the moment. And then you saw the other one was char. You remember if I go here, I go to type and it says char. That's kind of just a fancy way of saying that we want our data to be represented as a value. I guess I'll put plane C+4. And what that's saying is we want our data values to be represented 0 to 255 as an integer. And with 0 being the minimum, 255 being the maximum. Again, this should look familiar to you from P5 or a lot of other coding languages. This isn't something we're going to mess around with too much. The other one you could have is float 32. That's really there's some other more obscure ones, but float 32 would just be the minimum is 0.0 and the maximum is 1.0. This is more common for 3D graphics. They use a set of normalized values, but for the most part, we're going to be staying in this range just to start. And then dimension. We have the X and the Y dimension, and those can be anything, really. It's just the dimension of like what the width is and what the height is in terms of how many pixels we're representing. I guess I should say that. Pixels. It's just like the resolution of it. So if we have 320 by 240, that's pretty common. 1024 by 768, which I think is standard definition. And common with 1920 by 1080. And these are all usually 4 by 3 ratio or a 16 by 9 ratio of numbers. And the 4 by 3, that's just like the size, that's the ratio for what our screens are mostly made up of. This is kind of a, this is widescreen, and this is not widescreen. I can't remember the correct term for that at the moment. But so going off of what our camera has coming in, we'll do 1280 by 720. And I'll just, if you hold Option and drag across patch cords, you can grab them wholesale and move them over here. I love that trick. And nothing changes. We're just kind of, with these values right here, we're just reinforcing what exactly it is that we're seeing. I can go back to type, char, planes, 4, dimension, 1280 by 720. But I could also go in here and change the dimension. I could do 80 by 60. And now you can see we have this more digitized, or not digitized, but like pixelized version. I'll make this a little bigger so we can see. Whoa. Just start over here for a second. And I could also make this 32 by 24. And now we're actually getting something that's like properly pixelated. And I'm just downsampling the pixels right here with this. And it's sometimes I find it's like I said, this is kind of just a spreadsheet of numbers. And we can look at how that spreadsheet is represented with another object called jitcellblock. I'll put that here. That's also just another, I guess it's a kind of a GUI object. You don't really interact with it too much, but it's just an object where once you type it in, it turns into something. Put that to the side here. And if I hook this up here, now I have this kind of table array of different numbers. And right now, not a lot is happening. We're seeing 255, 255, 255. And it does correspond to something. We have our char data, and we know it's 0 to 255, so we know that I can actually grab this slider here, and I can look through every single pixel. And what this is a representation of 32 rows by 24 columns. Am I getting upside down? Yeah, 32 columns by 24 rows. Sorry about that. Of the first plane, and that first plane is the alpha plane. And right now the alpha plane is just completely white. It's just white pixel information because we're not using it. And that's kind of what the alpha plane defaults to. I'm going to make this a little messier. And just to show you something, I can say jit.unpack. I keep making these objects from out of nowhere at the hotkeys, but I want you to know where I'm coming from. This is an object, jit.unpack. And I send the matrix in, and it'll unpack each of the matrix, or each of the planes in that matrix. And we know that this is kind of set up to work with ARGB color information because there's 4 outlets, and it'll expect a 4-plane. I could actually go, if a matrix was 2 planes, I could say jit unpack 2 and it'd give me 2. But we know it's 4, so it's going to default to that. If I grab another one of these, this is the first plane, and you can see that it's just a white screen. And that's what we're seeing down here. It's just showing us each pixel that's coming in. It happens to be 255. But the second plane, since they go from 0 to 3, the second plane is actually the red plane. And I can tell this jitcellblock object to show me plane 1, again, with planes 0 to 3 equals ARGB. So plane 1 is red, and if I lock this, I'm just sending a message with the argument, like the method being show me a plane, and this argument is which plane I want you to show me. And now we're seeing these numbers move around. This is every single pixel coming in here and showing me how much red information is in it at any given moment. You can see the numbers are kind of jumping around because maybe my webcam is shitty, or like I have like a high frequency light in my room that it's just all you can see. Even though it's stable as an image, it's actually fluctuating really softly in like what the different color values are. And rather than unpacking just the alpha plane, if I move it over here, I can unpack the red plane. And we get this grayscale image. And at first it doesn't make sense. It's like, why aren't we seeing any red? And that it actually does make sense because we're only seeing one individual plane of the matrix. And when we only see one plane, we're only seeing a grayscale image. It's only once we mix it together as red, green, and blue that we actually get to see the color that's associated with it. So that's what's happening there. But if I jump over here, and you see it got a little darker, that's what I mean. Like, it's saying there's not as much green in this image, but in those same pixel locations, like right around my face, like a skin tone, there's a little bit more red information. I can put those side by side actually if I wanted to. And this is the green plane. And I can also send a message to the getcellblock -1, and that just says show me every single plane there is. And now, and like it's actually a little bit cut off. We can't even see the blue plane. That's cutting off the green plane a little bit. But there's that first plane, the alpha plane. There's the red plane. There's the green plane. Then hidden somewhere behind here would be the blue plane. And I can actually even downsample this down to, oh, I don't know, like 6 by 4. And I got to send this message again here. And now, I mean, like, it's so pixelized that we can't even really tell. You can kind of know. I'm moving around. Maybe you can see my head. Like, I think this, like, kind of fleshy white skin tone right here is probably my face moving back and forth. And what it's doing is it's taking that original dimension here, and it's just, like, cutting that whole area right here of all of its pixels. And it's just averaging what the average pixel would look like right there. And going back to this, I know I said I go using char data, and that's the 0 to 255. I could also say float 32. And now you can see what I was saying. Now the data is just represented as a value between 0.0 and 1.0. And yeah, I was going to say, well, there's other fun things we can do. I'll stick with the char data. I'll also bump this back up so it's like, yeah, 32 by 24. I was able to tell it's me. I'm going to get rid of this guy here for a second. I don't really need him anymore. Hopefully you understood where I was going with that. With the jit unpack, I'm going to have a little fun with. There's also an object called jitpack, and it's just the inverse of the jit unpack. This is the A plane, the red plane, the green plane, the blue plane. This expects 4 planes to be packed into it, and whatever plane it receives in here, it'll represent as the red information, the green information, the blue information. I'll just hook up the alpha to the alpha. That makes sense. And then I'll just keep going with that red to green, or red to red, green to green, blue to blue. Let me just get rid of that here so it's a little easier to read, and I'll keep that there. And we have something that's just the exact same here. But what if I took the red values and put them in the blue plane, and I took the blue plane and put it in the red plane, and now we're like swapping the colors around. I can take the green plane, then actually put it in the blue and put the red back into the, whatchamacallit here? Oh, no. And that's just, we can see how we can manipulate color based on like what plane we're working with and what's happening in there. And this is kind of, if we wanted to turn this into an effect, this is kind of annoying. So I'm just going to copy paste this, because we don't want to unlock the patch and hook up this patch cord and everything every single time. Like, it's just not a very efficient way to build an interface for ourselves. And the jit matrix object allows us to, there's a attribute called plane map, and basically what it'll say, plane map is, this is a method I should say, it's a method that expects 4 arguments. The first argument would be the alpha, and then the red, and the green, and the blue. And if I give it a number of a plane that already exists, if this is plane 0, plane 1, plane 2, plane 3, remember I can just hard code things into it with the @ symbol here. That's the attribute. And I can say 0, 1, 2, 3. Let's make a little more space. You get the idea with that at this point. And then again, we're seeing the exact same thing. But now I want to put the third plane where the red plane would be, so I could do that. And I want to put the red plane where the blue plane would be, and that would be the red plane being the first, or sorry, plane number 1 in the location of the blue plane. And I've done that same thing, I've swapped it around here. And I could also, let's see, how could I do that? I could also make a message plane map, and I want to keep 0 at 0, so I'm just going to hard code 0 into that. Then I'll do $1, $2, $3. And you should remember the $ situation from the JIT movie tutorial in the last one, where now we just need a 3-element list, and the first element will be put here, second element will be put here, third element will be put here. And I could make another message that goes 1, 2, 3. And now, I use this message just to visualize what's coming out. If I pass a 3-element list in here, 1, 2, 3, it'll put 1 at the 1, 2 at the 2, 3 at the 3. And we have a message that tells this object that its method, plane map, should have these arguments now and override this. So this would take me back to having a completely normal RGB image like that. But I want to turn this into effect. So I'm going to use the ZL object. ZL works only with list. I believe I touch base on it in the data types tutorial from the first week. And this is a bit obtuse looking at first. It's kind of crazy looking. There's a whole bunch of different things. Basically, it has different behaviors. It goes ZL, and then you give it a name, and that name is how it behaves. And there's one I like. It's just, what is it? I think it's called ZL Scramble. No, yeah, right here. ZL Scramble. And it says, it just scrambles the order of a list of items. And that's great, because I just want to scramble what this is. So I'll do ZL Scramble. And again, I'm just going to start getting rid of some stuff here. And now, actually, before I even do that, I'm just going to show you what's happening here. If I feed it a list of numbers, or even strings, or floats, it's just going to scramble the order of those contents. So if every time I send that to ZL Scramble, okay, it came out exactly the same. But if I hit it again, now it's a random order, and then a random order, and a random order, and a random order, and a random order. And now I can just hook this up to here, and I get my method argument with my method with its 4 arguments, but I'm scrambling the order of the red, green, and the blue plane of where they're represented. And I can just take my metro, and every time I get a new frame, I can also have it pass it a new color. And let's get this in all of its HD glory, or not HD, but 720. I gotta do it here too. Now we got our nice little rave effect, and we're like in the club, and like, oh my god, the lights, and like, oh, I'm rolling so hard, and yes, yes, yes. And yeah, that's just kind of a cool effect that you can build pretty simply, but mostly just to show you just like what the planes are and how you can move the planes around, how you can reconfigure them. But really what I want you to take away from this is there's 4 elements that really comprise what a movie image is made up of in jitter, or what's coming through the jitter signal. It's how many planes of information do I have, how are those pixels represented in terms of data type, and then how many, what's the width and what's the height, how many rows and columns of pixels do I have. And yeah, once we kind of understand it, that's what we're working with. I mean, like, everything in Max is just working with numbers and working with data. I mean, coding is in general, but like once we get a sense of what those numbers are and like really exposing them, then we get to have fun because we can start to imagine how we can manipulate those numbers and like munge them and break them and scatter them and slide them. And what's so fun about Max and Jitter is because it's such a visual thing, we get to see this immediate output of what when we do things to the data, we get to see it as an effect. We get to see it as like this visual reality. So yeah, with these two tutorials and some of the other stuff in the repo, I hope that you really just take some time to kind of dive in and experiment. Like I said before, if like there's something you don't understand or you're really struggling with something, I have office hours. There are a lot of residents that are super helpful and super knowledgeable about this as well. But the sooner you can kind of just dive in and start experimenting and start exploring, the more it's going to help you in this class. So yeah, let me know if you have any questions. Reach out to me at email. And yeah, I'll see you guys soon.